Okay, once again, last meeting had your quiz. Coverage was until here. Equilibrium of concurrent forces. Now let's move on to other examples. So we're done with number 2. Let's move on to number 3. And everybody ready your calculator for recitation and for quicker problem solving. Number 3, 3 bars hinged at A and B and pinned at B and C as shown in the figure form a 4-linked mechanism. Determine the value of P that will prevent motion. So prevent motion means all of this is in equilibrium. So what you're gonna do first, you have your figure, right? You're gonna create your free body diagrams. So let's start with that. I'm gonna start with pin B. Whenever you're given a truss like this or a frame, you're gonna create free body diagrams at these pin supports. In our case, I'm gonna start at B. So just follow the lines, the orientation, okay? And then usually for pin connection, reaction would be to the point, okay? So I'm gonna draw this. And this is my point B, so force AB is directed to it. So that's why this is my arrowhead. And again, this is your force AB. Next, force BC. Again, the assumption is it's directed towards your point. Remember, for creating free body diagrams, all your directions are assumptions. So you'll see in the final answer if your assumption is correct or not. So this is my FBC, and then we have an external force of 20 kilonewton. And I'm gonna follow the arrow, which is here. Remember in previous lectures, I drew my free body diagram always away from my points, right? Now that's not a rule. This is just what I'm comfortable with. But you can do it this way. As you can see, my arrowhead is pointing towards the point instead of away. Yeah. And then let's figure out our angles. So this is 45, this is 75. So let's draw that. Now the problem here is I'm gonna have two unknowns, right? So I need to create an axis. That'll make it easier for me to create my equations. Because if I follow the x and y axis, which is this, okay, it's not necessarily easy to figure out what these angles are. Right? Because this force, all I'm given is this is 45. I can figure out what this is, right? Since this isn't really to scale, this isn't an accurate representation, it's just a sketch. So what I'm gonna do is, I'm gonna use one of my forces as the axis. For this case, I'm gonna choose FBC as my horizontal axis. Okay, let's do that. And so again, this is my x-axis. And consequently, perpendicular to that is my y-axis. Okay. And then let's draw this again. This is your FBC. Now look here. Now I can determine 20 is 45 degrees from the x-axis. So it's easier to see my angles. Next, I need to figure out what this is. So just looking at the drawing, okay, I can say that this is 60 degrees. How? This total angle is 180. This is 45. This is 75. So 180 minus 45 minus 75, that's 60. Okay. So that's my FBD1. Do the same thing for C. Once again, I'm going to draw as is. I have my point here. This is my FCD, arrowhead towards the point. And then we have my FBC again. Now, one thing that's important is if you have connecting forces, for example, my FBC, you have to be consistent with your direction. My direction for FBC here is towards the point. So here, it should be the same, towards the point. Okay. I can't say that this is FBC and then I'm going to write here, this is FBC as well. Okay. You have to be consistent with your analysis. So once again, this is your FBC, and I have an external force P. Now, we encountered, once again, the same problem. Let me make this more obvious. Wherein, if I choose this as my X and Y, I need to figure out what these angles are. Okay. And then knowing this is 60, this is, whole thing is 45. Okay, it's not readily available to figure out what these angles are. So instead, I'm going to choose one of my forces as my x-axis or horizontal axis. Okay. So for this case, I'm going to choose FBC again. So this, and perpendicular to that is your y-axis. Okay. And let me just draw the angles. So between FBC and P, right, it's this, that's 60 degrees. Between P and FCD, which is this, that is 45. Okay. So now, as you can see, for P, I observed that the angle is 60 from the horizontal. So the only problem now is this FCD from the horizontal. You can figure that out considering this is 180, right? So 180 minus 60 minus 45, you get this angle 75. Okay, so there. That's how you create your free body diagram if X and Y isn't obvious. Now, next step, equilibrium of concurrent force systems. That's just summation of forces, vertical and horizontal equals 0, or X and Y equals 0. So let's start with summation of forces X using this. So summation of forces X equals 0. So let's start with FAB. FAB is to the right, even though this is your arrow or this is your force. It's still to the right, so therefore it's still positive. FAB, and since your angle is from the horizontal axis, we can use cosine for X component. So FAB cosine 60. Next, you have your 20, once again to the right. Okay, so positive 20, and then cosine 45. Next, you have your FBC, which is to the left, so minus FBC. Okay, so let me equals 0. So I'm just gonna rewrite this so that it's easier for you guys to solve for simultaneous equations later. So FAB cosine 60 minus FBC equals negative 20 cosine 45. So by now you should know we're just gonna label this as equation 1. Next, do the same thing for FY. So FY, let's start with FAB again. FAB is upward, therefore positive. FAB, then Y component, so sine 60. FBC doesn't have a Y component, so ignoring that. Next, 20 is downward, so minus 20 sine 45. And there's no other force, equals 0. And looking at this equation, I can directly solve for FAB. So please solve. What's FAB? Correct, John and Johnson. So Relor Bagba. It's 16.33 unit kilonewton. We're looking for P. So next step would be to store that. And then using FAB in equation 1, we can now solve for FBC. Please solve for FBC. What is it? Correct, Andre and Jasmine. So De La Vega and Alanis. Okay, so 22.31. Once again, store that because we're gonna need that in our next equation. So now I'm done with this free body diagram. Once again, our goal is to figure out P. And we start with the force with the least unknown, right? Here it's only 2 unknown, here it's 3. Okay, that's why I started here. Well, next, we can move on to the next free body diagram. Once again, let's start with summation forces X. Looking here, FBC is to the right, therefore positive FBC, directly on the x-axis. Next, we have your P to the left. So minus P, x component, so cosine 60. Next, FCD is also to the left. So negative FCD cosine 75 equals 0. Once again, I'm going to rewrite this so that you can clearly see our simultaneous equation. So negative P cosine 60 minus FCD cosine 75 equals, I already solved for FBC, so that's a constant now. So equals negative FBC. And that's your equation 1. Next, let's move on to summation of forces Y equals 0. Starting again with, let's start with P. So downward, therefore negative P sine 60. Next CD. Upward, therefore positive FCD sine 75. And then FBC doesn't have a Y component, so equals 0. Okay, 2 equations, 2 unknowns. We can solve for P. So please solve for P. In this case, there's no FBC, so this is just 0. Is it negative? Should be positive. If our answer is negative, that means your directions are incorrect. Okay, so should be positive. So Mark and Johnson got it correct. Villamor and Baluba. Okay, so 30.48. But did you use the 30.48? And then unit kilonewton. And that's the answer to this question. There. Do you have any questions for number 3? Number 2, please answer in the chat. Oh wait, no, this is number 3. Once again, any questions? Type it in the chat. Wala. All right. We can move on to the next. Number 4. Okay. Chords are looped around a small spacer, separating 2 cylinders, each weighing 400 pounds, and pass, as shown in the figure, over a frictionless pulley to weights of 200 pounds and 400 pounds. Determine the angle theta and the normal pressure N between the cylinders and the smooth horizontal surface. So we're looking for theta, and then we're looking for N. Okay. So first things first, let's analyze what's going on. This is your cylinder resting on a surface. Once again, whenever you have two objects in contact, there is a normal force between them. So let me just draw our free body diagram here. Normal force is towards the object and perpendicular to the surface. So this is my surface, perpendicular to that, normal, and then towards the object. So it's upward. So in your free body diagram, you have two choices. You can draw it this way. Right? This is your point. Or you can draw it this way. It doesn't matter as long as you're following your direction. So I'm going to draw it this way. It's still upward, so it still means the same thing. Next, I have your chords here. And remember, chords are most of the time away from your point. So this is my point. I'm going to choose this as my tension for your chord. I'm just following the direction of your chords. Okay. And then this is your theta, which is what I'm looking for. Now the problem here, what are these? Remember, and I'd like you to take note, frictionless pulleys mean that it's just changing the direction of your force. Magnitude will still be the same. So for example, here, you have this pulley. This string carries 200-pound force. So this being a frictionless pulley, that 200-pound force will just be distributed here. Okay? So therefore, this string is also carrying a 200-pound force. So that is 200 pounds. Okay? Same thing here. You have a 400-pound force. Even though it is at an angle, magnitude doesn't change, just direction. So this string is carrying 400, passes through the pulley, frictionless pulley. So the force it carries doesn't change. This string now also carries the 400-pound force. So 400. Solve kayo agad. Wait lang. Okay? And then, this has a weight of 800 pounds. And remember, weight is always downward. So I'm going to draw that downward, 800. Okay? And now we have your free body diagram. And now we can use our fx equals 0 and fy equals 0 to solve. Let's start with fx. Okay. So fx, so you got negative 200 plus 400. And this is x component, so cosine, then theta. And then this doesn't have any horizontal component, so equals 0. So now I can directly solve for theta, which some of you already did. It is correct, 60 degrees. Very good. So Skylar and Kathleen. So pamatmat and okay, very good. So that's part A done. Next is figuring out what is the value of n. And to get that, we use summation of forces vertical or y equals 0. So let's start with n. N is upward. This doesn't have a vertical component, so ignoring that. Next, this upward, therefore positive. Sine angle. So sine 60, since we already know that. And then downward, so negative 800 equals 0. Then now we can solve for n. What's the answer? Correct. It's 453.59. Skylar and Jermaine got it correct. Pamatmat board. Okay. So 453.59 unit pounds. There. Okay, so once again, take note, frictionless pulley just means distributing your force to another direction. Okay? So that's number 4. Do you have any questions for number 4? Please answer in the chat. Okay, great. None. So let's move on to number 5. It's a bit more complicated, but still pretty much easy. The cylinders in the figure have the indicated weights and dimensions. Assuming smooth contact surfaces, determine the reactions at A, B, C, and D on the cylinders. So pretty straightforward. We just want to know reactions at A, B, C, and D. And take note, they're all at surfaces in contact. So that means those reactions are your normal forces. Okay, so before we start, let's analyze. So remember, once again, normal forces perpendicular to your surface towards the object. So let's start here with your blue circle, blue cylinder. Reaction at A. So perpendicular and then towards your force. Okay, so it's this. So let's call that your RA. Same thing here, RB, perpendicular. And then, look here. We have the connection between blue and violet cylinder. So what's going to happen there? That's another example of normal force, two objects in contact. So this blue cylinder is exerting a normal force on your violet cylinder. While this violet cylinder also exerts a normal force on this. Okay? So these blue arrows represents the forces being experienced by this cylinder. So therefore, this also experienced a normal force from the violet one, which is here. Okay? So that's for your blue one. For the violet one, same thing. Here at D, perpendicular to your surface towards your object. So RD. And then we're also going to consider the normal force exerted by the blue one on the violet one. And it also applies that it is perpendicular to the surface and towards your object. So this is your surface, perpendicular to that, and then towards your object. Okay? So we have 3 normal forces, RA, RB, 4, RA, RB, RC, RD. So for this case, okay, these are both RC. They have the same magnitude. Similar here, I just didn't show it. This blue cylinder also exerts a normal force on the surface RC, but we don't need that. We're not solving for the force being experienced by your surface. We're looking for reactions at this point. So that's why you don't really draw that force, even though it's present. Okay. But here I need to because I'm concerned with both cylinders. All right. So how do I go about this? So first of all, you're going to draw your free body diagram. You can base it here, or you can create a separate drawing just to make things clearer. So let's start with the blue one. Okay. My RA is to the right, so I'm going to draw it that way. Okay. Once again, if you want, you can draw it this way. It's the same thing. This is just my preference. Next, I have a RB, so upward. So I'm going to draw it that way. And then my RC is towards the point downwards to the left. So that is what I'm going to draw. Downwards to the left. Okay? Remember, definition of free body diagram. Forces acting on the body. We don't include forces acted by or created by the body. Okay, just on. This violet RC is the force created by your blue cylinder. So ignoring that. This blue one, this blue force is the force exerted by your violet one on your blue cylinder. Okay, so that's why that is the choice of force. Okay. And our problem is, I don't know. I don't have an angle. I don't also have this slope, right? So what you're going to do is you're going to look again at the drawing and figure out how to get that dimension or angle. So I'm given a radius. Now look here. What if I do this? Have myself a right triangle. Now if I can just figure out these dimensions, I can get the slope of these two forces. Okay? So how do I get that? So this is, I can already figure this out, right? radius is 2 for blue one. So therefore, this is also 2. Correct? So this is 2. Okay. And then this is 1. Right? Radius 1. So this distance is also 1. So now I have a hypotenuse. Next, how do I get this? Well, look here. Okay. This whole thing is 5.6. This radius is 2 and 2. So I can say this entire thing is 4. Right? And then this entire thing, right, is the radius of the smaller circle, which is 1. This is 4, this is 1, the entire thing is 5.6. I can figure out this length now. Okay. So now it's just 5.6 minus 2 minus 1. Okay, gets? Again, this is also 2. This whole thing is 5.6. So 5.6 minus 2 minus 1, I can get this length. Okay. So 5.6 minus 2 minus 1 is 2.6. Tanggalin natin. So this is 2.6. So remember, whenever we're given slope, we have the choice of using that slope. Or if you don't want to do that, you also have the choice of just figuring out the angle. And that is what I'm going to do so that you can also learn that technique. I'm going to figure out the angle of this right triangle, which is also the same as the angle of my force. Okay. So once again, let's draw that right triangle. This is 2 and 1, therefore this is 3. This is 2.6. This is your theta. Using cosine, cosine theta equals adjacent over hypotenuse 3. Therefore, solving for theta, you get 29.93. Correct, Skylar and Nicole. Now you need to store that, because you're going to use it now in your equation. So, Forest. Skylar already got 2 points. Okay, and that theta is the same as this. Right? Looking at the drawing, it's the same as this line. So that's theta. Therefore, this is also theta. Okay? Having that 3-by diagram, I can create my equations. So let's start with fx. Summation of forces x equals 0. You got negative r c. Okay. So negative rc, since to the left, cosine theta. Once again, this is your theta. RB doesn't have a horizontal component. So next, RA to the right plus RA equals 0. Nothing to solve for there. So equation 1. Oh wait, no. May kulang. May weight na 400. To include that, weight 400. Next. Summation of forces y. Summation of forces y equals 0. So RC is downward. Negative RC sine theta plus RB since upward. Next, minus 400 since downward equals 0. That's your equation 2. Nothing to solve for yet. Yeah. Okay, next. Let's create a free body diagram for the smaller circle. So let's start with weight. Weight is always downward. So weight downward, 200. Next, we have your RD to the left. So RD. Next, RC. Again, we're looking for forces on the object, experienced by the object, which is this. So this is my RC. And then angle, the same as this, is still your theta. Okay. Let's start summation of forces x equals 0. So negative RD plus RC cosine theta equals 0. Nothing to solve for there. Once again, let's say equation 3. And then finally, summation of forces y equals 0. RC is positive there because it's upward. So RC sine theta minus 200 equals 0, since RD doesn't have a vertical component. And from this equation, I can finally solve for a variable, which is RC, since it's the only unknown. So please solve for RC. What's the answer? It's correct, Angela and Kathleen. 400.85, garing Gupra. So 400.85. So that's the first answer. And then unit was kilonewton. So store that, because now you're going to use that in equation 3. So using 3, you can now solve for RD. Solving for RD, what do we get? Again, if you use the stored value, okay. No. No. Okay, kaya pala. So, the incorrect. So, it's supposed to be 400.89. Okay, then store. And then using 400.89, you can now solve for RD. Yon, correct, 347.44. Correct, Jermaine and Joanna and Mark. Corbe, Tamano, kaya biyan. Corbe. Tamano and kaya biyan. Tamano pala, Tamano. Okay. So it's 347.44. Again, store that. Can now solve for what's using RD. Nothing. Wait. RC. Yan. Okay. So after using in 3, you can now use in 1, right? To solve for R8. Mm-hmm. Ayan. Bakit naging 600 sagot niya? RA hinahanap ko. Ayan, using equation 1. So RA is you're correct, Jermaine and Angela. It's 347.44. Okay, and then lastly, to solve for, we have A, solve for RB. We're gonna sub this in RB. So using sub RC in equation 2, solving for RB. Ayan, correct, Kathleen and John. It's dun yung 600. Okay, Dupra, Relor, Reyes. Okay, 600 if you use the store function. And all of my answers are positive, therefore all of my assumptions for direction is correct. So this is what happens if you don't start with the free body diagram with the least amount of unknowns. Okay. As you can see, you keep going back to your previous equations just to solve for it. You can do it that way, it's just longer. So I'm just showing you what happens if you don't choose the FBD with the least amount of unknowns. Okay? Good. So that is number 5. Any questions for number 5? Okay, wala. We can move on to the next one. I think that's the last 4 concurrent force systems. Okay. We can now move on to resultant or equilibrium of parallel forces. So once again, same analysis. The only difference is you're equating everything to 0. And since this is parallel forces, we introduce the concept of moment, similar to your resultant. So we have Fx equals 0, Fy equals 0, moment equals 0. So now these are your 3 governing equations for equilibrium of parallel forces problems. Let's immediately start with the solution and problems. Okay, number 1, determine the reactions R1 and R2 of the beam loaded with a concentrated load of 1,600 pound and a load varying from 0 to an intensity of 400 pound per foot. So this type of problem is something that you will commonly encounter in higher subjects, looking for reactions. So this is an important skill you need to learn. Granted, this is more complicated than the usual question. So the goal here is to look for R1 and R2. So when you have something like this, you have 2 beams on top of each other. Right? You're gonna work on 1 beam at a time, starting with the beam with the least reactions, or the outermost beam, which is in this case, the one carrying your distributed load. So let's create a free body diagram of that. You have this, you have your load. Okay. 400 pound per foot. And then you have these objects. So this means a roller. Okay. And for a roller, the only reaction it can give is vertical reactions. Okay. Because it cannot prevent horizontal motion. So for a roller, it's only vertical. Now for a pin, which you'll see later on, looks something like this. This one has vertical and horizontal reactions. Okay. So roller, only vertical, pin, horizontal, and vertical. So we both have rollers, so there's only vertical reactions for each. Let's call that your RA. Let's call that your RB. Okay, so to solve for this, first step is moment. Summation of moment. Then you're gonna choose. Usually, you're gonna choose your points at the reaction. So either at A or B. Let's say I want to take it at A. Summation of moment A equals 0. Okay. So moment A, RA is at A. So therefore, that cancels out. Next, 400-pound force. Remember, that creates a point load of or equal to your area of this distributed load. Okay. And then this distance is 1/3 of your length. And this length is given to be 12. So this is 12. So this is 1/3 of 12. Therefore, this is 2/3 of 12. Okay. So let's start with R, rotating R about A. That is clockwise, therefore positive, and R is just, again, area of your distributed load. So 1/2 base times height. 1/2 base is 12, height is your 400. Then distance from your point, again, it's 2/3 12. Next, RB, rotating RB about A, that's counterclockwise. Negative RB, distance 12, and then equals 0. I can solve for RB. What's the answer? Okay, correct, Jade and Joanna. So, Tamano and Simon. Simon, 1,600 pounds. So positive, therefore my assumption for direction of reaction is correct. It usually is upwards, but not all the time, okay? Again, these are just assumptions for direction. However, R is obviously downwards since my forces, distributed forces, are directed downwards. Okay, next is to solve for RA. Solve for RA is easy. That's just summation of forces vertical. Since everything is vertical, equals 0. So looking here, RA is upward, therefore positive, minus R. Once again, R is area of your moment diagram. So 1/2 base times height. And then plus RB. And RB is 1,600, then equals 0. Solve for RA, what's the answer? Correct, it's 800. So John, Santa Ana, Shanine, then Kathleen Dupra. Okay, so Santa Ana and Ivy, correct. Johnson. Okay, nice. So once again, it's 800 pounds. What am I gonna do with that information? Well, now you can move on to your actual beam, your lower beam. So creating another FBD there. Okay. Direction of R1 and R2 already given. Okay. Next, you have a 1,600-pound point force here. Now, the reactions are gonna be distributed to your lower beam. Okay. RA, RB upward. Remember, whenever you're, or towards the beam, whenever you're transferring forces, it should have consistent direction. So upward towards your beam, so forces here should also be towards your beam. So this is now my RA. This is my RB. Okay? And then let's write out the direction, the distances. This is 3, this is 1, this is 12. Okay, so goal is to solve for R1, R2. So usually for first step again is summation of moment equals 0. Now take a point. I'm gonna choose this point since RB and R2 are there, so both forces will cancel out. Summation of moment at 2 B equals 0. Starting with R1, rotating about B, that is clockwise, therefore positive R1 times distance, 12 plus 1 plus 3, 16. Correct. Next, 1,600, rotate it about B, that's counterclockwise, so negative 1,600, then distance 12 plus 1, 13. Next, RA, rotate it about B, once again, that's counterclockwise, so minus RA times distance 12. There's nothing else, RB and R2 passes through B, so ignoring that, equating to 0. I can now solve for R1. Please solve for R1. What's the answer? Correct, John and Angela, Garing, and Mark. Garing, William. Okay, 1,900. So that's one of your answers. Positive answer there for correct assumption. It is indeed upward. Next, to find out R2, we can just use summation of forces vertical. And so R1 is upward, therefore positive, minus 1,600 minus RA minus RB plus R2 equals 0. Now I can solve for R2. What's the answer? Okay, correct, Mark, Angela, Shani, correct, and then Jasmine, so Santa Ana, Alanis. Santa Ana. Okay, it's 2-1. So 2,100 pounds. And that's it. That's how you solve for reactions. It's usually just a combination of moment and summation of forces. And ganun lang. So once again, this is a skill that you need to master, especially for your CE students or for your CE students. So that's number 1. Do you have any questions? Please answer in the chat. Okay, how about the others? Okay, all right, great. Let's move on to number 2. Okay. A roof truss is supported by a roller at A and a hinge at B. Find the values of their reactions. So another problem, just looking for reactions. This is number 2. Right? Okay. So we've solved for a problem like this before, right? So now we're only concerned with reaction. Now I want to know, we're only concerned with resultant of all of this. Next, I want to know the reactions at your supports. This is what you call your supports. This is another way to draw your roller. Once again, a roller only has vertical reaction, so we can draw that. For this case, it's safe to say that my reaction is upward. Because remember, reaction is something that puts your system in equilibrium. All of these forces are downward. Therefore, it's safe to say my reaction at A should be upward to cancel everything out. Same with here. This is a pin. That's another way to draw your pin. This has vertical and horizontal reactions. So we have another vertical reaction. Again, I'm going to assume it's upward since all of my forces are downward. So it can counter that. Now this this can have a horizontal force. But that's only going to happen if we have horizontal or diagonal forces, okay? This system doesn't have any. So reaction here, horizontal is just 0. So we don't have to include that anymore. But I'm going to write it out just so RBH for horizontal reaction would be 0. Okay? Once again, you don't have to include that if there's no horizontal or diagonal force. Okay. So remember, to get reactions, usually summation of moment followed by summation of forces. So to get summation of moment, you're going to choose a point. Let's say I'm going to choose A. I'm going to need to know perpendicular distance of 20 from A. So I'm going to need to know this. And we've done that before. We already know the way to get that. So first, it's by considering this right triangle here. Okay, I can solve for L. Cosine 30 equals adjacent. So L over hypotenuse. My hypotenuse is 5. Therefore, L is just 5 cosine 30. Next, my goal actually is to get X. What's X? Here. This is the X. Okay, that's the perpendicular distance of your 20. So to get X, now I'm just gonna get this right triangle. Okay? So considering only this, still using your angle 30, cosine 30 equals adjacent. Now my adjacent is X over hypotenuse. In this case, hypotenuse is L. So X is equal to L cosine 30, and L is just 5 cosine 30. So I can solve for X. What's X? X lang hinahanap ko. That's reaction already. Correct, it's 3.75. So correct, Mark and Ivy, Johnson and Kayabil. Okay. So now knowing that, I can use my equation, summation of moment at A equals 0. 10 kilonewtons passes through A, so ignoring that, next 20. Rotate about A, that's clockwise. So 20 times 3.75, right? That's your X. Next, 60. It's again clockwise. So 60 times distance 5. Next 20, clockwise. So plus 20, perpendicular distance. This is symmetrical, therefore this is 2.5. Okay, you can do that. 2.5, so distance of 20 from A is 5 plus 2.5, that's 7.5. Next, 50, again clockwise, so plus 50, perpendicular distance, 10. Next, another 20, clockwise, so positive. Perpendicular distance, if this is 3.75, okay, so this distance would be 15 minus 3.75, and that's 11.25. Okay? Once again, that's 5 plus 5 plus 1.5. So that's 11.25. Okay, let's include that. This is 1.5. 1.25. And then lastly, no, I still have another 10. It's clockwise, so plus 10, 5, 10, 15 times 15. And then lastly, RB, counterclockwise, minus RB times 15 equals 0. I can now solve for RB. What's the answer? It's a pretty long equation. Correct. Correct, Andre and Kathleen Sayorda at Dupra. Okay, so De La Vega and Sophia, correct. De La Vega, De La. Yeah, 93.33. Yes, 2. Baka wala kayo nung sinabi ko, but Recitation is maximum of 2 points per meeting. You can exceed that if no one else is answering and you're the only one who answered. So you can get more than 2. Okay? So maximum 2 per meeting. So once again, that's 93.32. So that's my first answer. And that's why I'm not giving some of you points even though you got it correct, because you already have 2 points. So I'm choosing the next ones. Next, summation of forces, vertical equals 0. So RA is upward, so positive, minus 10, minus 20, minus 60, minus 20, minus 50, minus 20, minus 10, plus RB equals 0. And now I can solve for RA. Correct, Skyler. It is 96.67. Bakit yung tagay? Aming question. Correct, Jan. And then correct, John Carlo. And then correct, Mariah. So, Jan, Nicole, Torres, and Reyes. Reyes. Torres. Yeah. 96.67 kilonewton. Okay. So that's one way to solve for all of that. I'm gonna teach you now the shorter way, the faster way, which some of you might already know. So let me copy that. Okay. I'm gonna place it here. Make it smaller. Okay. And now take note. Look at this. This is 10, 20, 20. It's 10, 20, 20. They are symmetrical. Okay? So when you get a symmetrical system of forces, it's easy to get their reaction and position. It's just summation, and then position is at the center. So if I take the summation of these forces only, okay, it's gonna be here. Okay? This is where that reaction will be, at the center. And then to get the magnitude, it's just summation of forces. Yes, this is Photoshop. You can do that. So just take the summation of all of that. If you're taking the resultant, you can do that. So 10, 20, 20, 10, 10, 10, 20. So that's all of that is 80. I can just rewrite all of that as 80 acting at the center. Okay? Once again, you can only do this if it's symmetrical. If it's not symmetrical, you have to solve for the resultant and position of your forces. Just gonna be a longer process. Here, it's symmetrical, therefore it's just at the center immediately. Okay? And then 80. So now I just have these forces. So solving for that. Summation of moment at A equals 0. Let's start with 60. 60 times 5 clockwise, therefore positive. Next, R, which is 80 clockwise, therefore positive. So 80, distance is 5 plus 2.5, so 7.5. 50 clockwise, and 10. And then RB, counterclockwise, therefore negative, times 15 equals 0. You can directly solve for RB. What's the answer using this equation? It's 93.33 if you solve for it. Okay. Correct. So yeah, correct. Jan, Carla, Batun, and Faunie. And Pauline. So Batun and Faunie. So it's 93.33, which is the same as my answer earlier. But if you've noticed, the solution is significantly shorter. And then to get RA, it's once again summation of forces vertical equals 0. That's just RA minus 60 minus 80 minus 50 plus RB. And if you solve for RA, you're going to get the same answer, 96.67. Yes, correct, J. Kilonewton. Okay? So this is an example of knowing how to get your resultant. Makes your equation a lot shorter. See? Compare this to this. Yeah. So yun. That is 2 ways to solve for number 2. Any questions for number 2? Okay, good. So that's number 2. We can move on to the next problem. Just number 3. The cantilever beam is built into a wall 2 feet thick so that it rests against points A and B. The beam is 12 feet long and weighs 100 pounds per foot. So walang tanong. But most probably, this problem is asking for a reaction at A and B. Okay? So analyzing this, what we got here is a beam with weight. Usually our beams are weightless or negligible weight, but here it's given, so you have to take that into account. And then it rests against points A and B. Remember, whenever two objects are in contact, they have normal force. So your beam is in contact with B and at A, so there's gonna be normal forces there. Okay? In this case, those are what we call your reactions, because this beam is supporting, or this wall is supporting your beam. So reactions at A and B, supports at A and B. So let's solve for that, supports at A and B. Okay. So this is number 3. Okay. So first, I'm gonna redraw this. Okay. You can redraw a beam into just a line. And then I'm gonna copy your forces. This is your 2,000 pound. Next, this has a weight. So that weight is equal to your distributed load. Okay, so your distributed load is in the form of a rectangle. So I can just, therefore the position of the equivalent point load of your distributed load, or the resultant of your distributed load, is just at the center. Let's draw that. So center is here. So that's your R. Or again, that's the equivalent point load of the weight, which is, this is 100. This total length is 10 plus 2. Therefore, that's just 1,200. Yes, 1,200. Again, 100 times total length, 10 plus 2. And then distance, since total length is 12, this distance therefore is 6. Okay? And then you have reactions at A and B. Remember, reactions are, or in this case, these are normal forces towards your object, so towards your beam. So let's call that RB. And here, let's say this is your RA. Once again, these are all assumptions of direction. It's not always correct. Okay? And then since this is 6, this is 2, this is therefore 4. So now I have my free body diagram. I can solve for B and A. Once again, first step is usually summation of moment. So you're going to choose, usually you take your moment at the support. So it's either at A or B. Let's say B. Summation of moment at B equals 0. Let's start with the 2,000 pound force. About B, that's counterclockwise. So minus 2,000. Then distance is 6 plus 4, which is 10. Next up, your weight, 1,200, about B. Once again, that's counterclockwise, so minus 1,200, perpendicular distance is 4. RB is at B, so ignoring that. Next, RA, it's clockwise, so plus RA, perpendicular distance 2, equals 0. So please solve for RA. What's the answer? Correct, Jan and DeAndre. 12,400. Taurus. Oh, 2 ka na pala, Taurus. So, iba yon. And correct, Angela. And correct, Philip. So, pamitan. Iba yun. H5. 12,400. Unit pounds. Positive answer, therefore the assumption of my direction is correct. Next, summation of forces vertical equals 0 to get RB. So looking here, 2,000 is downward, negative 2,000 minus 1,200 plus RB minus RA equals 0. I can solve for RB. What's the answer? Correct, it's 15,600. Correct, John. Correct, Sophia. Correct, Jade. De Leon. And then correct, Vivian. Vivian. De Leon. Okay. Correct, it's 15,600. That's it for number 3. Okay. Yeah. And with that, we can directly move on to number 4. Number 4. Number 4 is a bit tricky. So the two 12-feet beams shown in the figure are to be moved horizontally with respect to each other, and load P is shifted to a new position on CD, so that all 3 reactions are equal. How far apart will R2 and R3 then be, and how far will P be from B? So what does that mean? So basically, I want to move AB, this beam right here, horizontally in such a way that R1, R2, and R3 will be equal in magnitude, and I'm going to move P as well to make that happen. And then the question is, what will be the distance between R2 and R3, and what will be the distance of P from distance D after moving everything? Okay? So let's draw that. Let's draw the final position of your beams. So this is your R1 and R2. Okay, the position of your reaction doesn't change. It's still your R1, R2. Okay, and then the distance between them is still 12. Now the question is, if I want R1 and R2 to equal to each other, okay, the only reaction that is, or the only force that will be acting on this is the reaction at C, because we have a roller there. So if I isolate this beam, it's going to be a reaction at C. Then that reaction at C will transfer to my beam AB. It's going to be this wave, RC, right? So can anybody tell me, where should that RC be so that R1 is equal to R2? Once again, where should this reaction be so that R1 is equal to R2? Considering our equation moment equals 0 and forces equal 0, where should this be? So that R1 is equal to R2. So this is an analysis. Okay, anyone? Correct. Correct John and Jade. So first two to get it correct. I'll give it to Ailey and John Carlo as well. So 4. Delor, Simon. Puro ka typo. So Delor, Simon, Ortega. Very good. Ailey. Delor, Simon. Okay, very good, guys. So it should be at the middle. Why? Because if I put it anywhere else, let's say here, and I take summation of moment, one of these two will be greater than the other. Okay? If I take RC here and I take moment at A equals 0, okay, the two forces, or these two, will have an equivalent moment. Or rather, these two will have an equivalent force. Okay? So therefore, this is at the center. So this is now 6. This is 6. Okay? Also, another thing to note, looking at this drawing, if I want R1 and R2 to equal to each other, the forces should be symmetrical. Okay? So that left side is equal to the right side. Okay? That's another way to look at this. So let's say I have 3 forces. They have to be symmetrical. Okay? That's one requirement, so that R1 equals R2. Okay? Because for symmetrical systems, left side equals right side. Okay? So that's one problem down. Next problem is here. Okay? We're gonna have RD here, R3. So my problem now is, where should I put this P? So let's say this is X. This total length is 12, 9 plus 3 is 12. So therefore, if I choose this as X, this is just 12 minus X. Okay? So now this is the new free body diagram. And take note, R1 equals R2 equals R3. So I can just call all of that as R. Okay? So after drawing my free body diagram, I can basically get my equation, or create my free body, create equations out of this. So let's start here, okay? Using this free body diagram. Summation of forces vertical equals 0. So R1 is upward, therefore positive. RC is downward, therefore negative. Then R2 is upward, therefore positive. Equals 0. And remember, R1 equals R2 equals R. So R minus RC plus R equals 0. So therefore, RC is just equal to 2R. Okay? Now I have this equivalent equation, RC equals 2R. I can use that in my free body diagram for this part. Okay? So let me redraw the free body diagram for that part. So we got RC. Okay. Remember when you're not repositioning, but transferring the force. Okay, you have to be consistent with your direction towards your beam. So therefore, this is towards your beam as well. So RC, and then P is here, and then this is X. And then this is just 12 minus X. And then this is your R3. Okay, let's create an equation using this. So let's say summation of forces vertical as well. So RC upward minus P plus R3 equals 0. Look, RC is 2R. I can rename this as 2R minus P. And what's P? 960 plus R3. R3 is also equal to R equals 0. So therefore, I can solve for the value of R. And what is that? Please solve. What's R? Correct. Carla and Nicole and Carla as well, Janine. So, Ibarra ba to? Ibarra ba to? Okay. So 320. So what am I gonna do with that? I'm gonna use this to figure out this distance x using moment. Okay. So let's say summation of moment at c, so that I can solve for x. Well, 0. Okay. So RC cancels out. So next is p. That is clockwise about c. So positive p times x. Next R3, counterclockwise. So minus R3. Distance is this total distance is just 12. So I can write 12 equals 0. And I already know what R3 is. That's 320. So I can solve for x. What's x? Correct, it's 4. So correct, John, Pauline, and Patricia. Tony Cruz. And then Cruz. Okay, so 4. Now look, what are we looking for? Okay, let's look back here. How far apart will R2 and R3 be? And then how far P will be from D? So we can solve for the first question. How far are R2 and R3? I can already directly solve for that. This is R2, this is R3, this is L, so we're solving for L. Okay. And to get L, take note, this whole distance is 12, right? And 9 plus 3 is just, this whole thing is 12. And we have already established this is 6. So to get L, that's just this length minus this length, right? 12 minus 6. So that's just 6 meters. That's the answer to that. And then, next problem is, how far is P from D? And this is D. So that's just 12 minus x. So 12 minus x is 4. That's just 8. So those are your answers. So this for letter A, this for letter B. Okay? So that is how you answer number 4. Any questions for numbers 3 and 4? Bakit masakit leeg mo? Ano ba posisyon mo? Ah, okay. Pwede na kayo mag-stretching. Tapos na tayo mag-solve. Para sa mga nangangawit dyan. Hey, so since it's 1:30, I'm gonna end that there. Although we still have 2 more problems, I'm just gonna discuss that later or just show you the solution, okay? So we're done with module 1. Later, okay, but we're not done with the activities. Okay, wait lang. Huwag muna kayo umalis. Wait lang. Next up, we're gonna have a group activity. Okay. So I need you guys to group yourselves into 5 to 6 members each. Okay, so 5 to 6 members. I'm gonna give you a break about ilang minutes kailangan yung break. Yun muna. Ilang minutes kailangan. Grouping to ha. Oh, hindi pwede 45. Mauubos oras natin. How about the others? Ilang minutes gusto nyo? Max 30. Hindi kaya 45, mauubos oras na. Okay, so maximum 30 na. So 30 minutes, sure. Okay, so you're gonna have a 30-minute break. So we're gonna go back at 2 o'clock. Okay, 2 o'clock. And by 2 o'clock, I need to find out your group members. Okay? So, uh, again, 5 to 6 members, group yourselves during that break. When we come back, give me your members. You can just type it here in the Zoom chat, direct message. Just let me know who your group members are. And then I'm gonna explain to you what your group activity is. By the way, after grouping yourselves, create a way for you guys to communicate with each other. Either you create a GC, you wanna create your own video call, group call, bala kayo. But this needs teamwork. Okay? So the group activity later, you will need knowledge from everything I've discussed so far. So review everything I've discussed so far. And some random facts. Yun. Yun lang. Once again, 30-minute break, come back at 2 o'clock. Group yourselves into 5 to 6 members, 5 or 6 members. Type it in the chat, sino-sino kayo. And then create your way of communication. And make sure to review everything I've discussed so far. Yun lang. Yes, we have a... No, we don't have a FB Messenger, sorry. Only group. Wala kayong GC. You can create your own if you want. May gumawa na eh, ang alam ko. Someone already created your GC. So, pasali na lang kayo. Yan, pwede kayo mag-usap dito sa chat. Okay, use this time to find out your group. Okay? And we'll see you later, 2 p.m. Go take your break. Bye-bye.